Okay, question number 5. As ever, it's handy to have a quick sketch. So the line L makes an angle of 30 degrees with the positive direction of the x-axis. So we've got some line L making an angle of 30 degrees. Find the equation of the line perpendicular to L, but passing through the point 0, minus 4. So it's passing, let's just draw a quick sketch. It's passing through the point 0, minus 4, but it's perpendicular to L. So something like that, okay? It doesn't need to be perfect, but I'm just getting a feel for what's happening in my question. Now, that means for this line, here we need two things. Well, first thing we're going to need is its gradient, but we don't know anything about its gradient, but we do know something about the gradient of L. So the gradient of L is tan of the angle it makes with the x-axis. So it's tan of 30. Tan of 30 degrees, pop that in the calculator, you get 1 over root 3. You might get a decimal version of that, but it's much tidier writing 1 over root 3. Perpendicular to 1 over root 3, well, if this is 1 over root 3, that's positive, so the perpendicular will be negative. That's 1 over root 3, flip it upside down, we get root 3. So minus root 3 is our gradient of this perpendicular line here. Now we can use what we know about lines. We can use y equals minus root 3x, so putting our gradient into y equals mx plus c. And now we can put in the point 0, minus 4. Now I'll point something out in a second, which is a nice little shortcut we can take here, but let's pretend we haven't spotted the shortcut. And just do it the long way, and then see why that we didn't need to. Here that gives us nothing, so c equals minus 4. And so y equals minus root 3x minus 4. Now there is that shortcut I talked about. This point here is actually the y-intercept of that perpendicular line. By drawing a picture, that really helps us see that's the y-intercept. So we always know that in the form y equals mx plus c, c is the y-intercept. So it shouldn't be surprising that c turned out to be the minus 4 there. So actually you would be totally allowed to take that as a shortcut. If you spotted that, you don't need to do any more line equation calculation once you've spotted that little detail. You can just go jump straight to here without doing any substitution. But if you didn't spot it and you do the work, there is no harm done. And one more example to go, so solution 6 coming up in a moment.